Section 15B.2, question number 2, page 366. Guess I could change that to a 2 because that's the question we're working on. Now, after that exhausting work in the investigation on page 365, we found that if y equals g of u, where u was f of x, i.e. this is a composite function, then dy by dx was given by dy by du multiplied by du by dx. And you could see then that the two du's would cancel because if you have the same thing top and bottom of a rational function, it'll just simplify down to 1, which then gives us just dy by dx. So there's the derivative of the function of u with respect to y, derivative of y with respect to u, and then the derivative of u with respect to x. And when you multiply those two together, you get the derivative of y with respect to x. So this is how you find the derivative of a composite function. Otherwise, that's in Leibniz notation. Otherwise, if we're given it in function notation, if you've got y equals to f of x to the exponent n, then dy by dx is equal to n f of x to the n minus 1 multiplied by f prime of x. Okay, so those are the two forms of finding the derivative of a composite function, i.e. the chain rule. So after going through that investigation, you would have realized these two rules, or these two forms of the rule for taking a derivative of a composite function. And now for question number 2, we'll go about finding the gradient function dy by dx. So in part A, when y is 4x minus 5 all squared, then dy by dx is 2, so we're bringing the n down in front, so in this case is a 2, and then we leave 4x minus 5 here, and we subtract 1 from the exponent, which just gives us 1 here, and then following this we take the inside, f of x, and we take the derivative of that, and the inside derivative of the 4x minus 5 is just 4. And then we can simplify by bringing this 4 to the front and multiplying by the 2 to give us 8 quantity 4x minus 5. In part B, we're given that y is 1 over 5 minus 2x, which I will just rewrite as 5 minus 2x to the exponent negative 1. Then dy by dx, again I'm going to take this exponent, bring it down in front to give it negative 1 out front here, leave the function on the inside just as it is, and subtract 1 from the exponent, so negative 1 minus 1 is negative 2. And then I go inside here, just like I've shown here, f prime of x, take the derivative of inside, which is negative 2. So then I'll bring this to the front, gives me 2, 5 minus 2x to the negative 2, and then rewriting it in the form that was given initially, in rational form, we get 2 over 5 minus 2x squared. And now for part C, y is the square root of 3x minus x squared, and I'll change that into exponent form to make finding the derivative a little bit easier. And now I'll go ahead and find the gradient function by differentiating. So I bring the 1/2 down in front, leave the function inside just as it is, and subtract 1 from the exponent. So 1/2 minus 1 gives me negative 1/2. And now multiply that by the derivative of the inside. So I'll go inside here, the derivative of this is 3 minus 2x. Now usually what I like to do is just take this smaller part and put it to the front. So I get 1/2 3 minus 2x multiplied by 3x minus x squared to the negative 1/2, and then I'll return it back to its original form in root form. The 1/2, the 2 is already in the denominator, and this part is in the numerator, so I've got 3 minus 2x all over, and that 2 here, and then this is in the denominator because the negative exponent, and the 1/2 gives me a square root, so you get 3x minus x squared all under the square root. In part D, y equals 1 minus 3x to the power 4, and then just do the same process. Find the gradient function by taking the derivative of this. Take the exponent 4, bring it down in front, leave the inside function just as it is, subtract 1 from the exponent to give me 3, and then go inside, take the derivative of that to give me negative 3. Now bring this negative 3 to the front just to clean things up a little bit, so you get negative 12 quantity 1 minus 3x cubed. Now I'll save a little bit of space here and go over to the other side of the page, and I will proceed with question E here. So y equals 6 quantity 5 minus x cubed. Same sort of process. Now we have a coefficient in front, but that's not a huge issue. When I bring this 3 down in front, when I differentiate, I multiply by the coefficient. So I get 18, 5 minus x squared, because I subtract 1 from the exponent, and then multiply by the derivative of the inside, which gives me negative 1. And then bring that negative 1 to the front, just to tidy things up a little bit, to get negative 18, 5 minus x squared. Part F, y equals the cube root of 2x cubed minus x squared, which I will rewrite as 2x cubed minus x squared all to the exponent 1 over 3. And then dy by dx, the gradient function is, bring this 1/3 down in front, 1/3 quantity 2x cubed minus x squared, and then subtract 1 from the exponent 1/3, so I get negative 2/3, and then I go on the inside in here and take the derivative, so I get, bring the 3 down in front, multiply by the 2 to give me 6, subtract 1 from the exponent to give me x squared, and then bring this 2 down in front to give me negative 2x. And then I'll just bring this to the front. I tend to like having that part with no exponent at the front here. And then to return it to the previous form, the given form, this 1/3, that 3 is in the denominator and the 1's in the numerator with this bracket here, the 6x squared minus 2x. So that would give me 6x squared minus 2x all over, and the 3 stays in the denominator. This is in the denominator because of the negative exponent, and then we got this rational exponent here. So it's the cube root of 2x cubed minus x squared squared, and we'll just leave it like that. Moving along to part G, I'll write this down here. The function y equals 6 over 5x minus 4 all squared. And writing in exponent form, 6 times 5x minus 4 to the negative 2, dy by dx is equal to, and then I take this negative 2, multiply down with the 6, so I get negative 12, 5x minus 4, leaving that function on the inside just as it is, subtracting 1 from the exponent here to give me negative 3, and then going to the inside and finding the derivative, which is 5. So I bring that to the front, gives me negative 60, 5x minus 4 all to the negative 3, and then I'll bring this back down into the denominator to give me negative 60 over 5x minus 4 cubed. Sorry, that last part was cut off there, and so it's negative 60 over 5x minus 4 cubed.